MTD CNC, bringing you the latest engineering news, reviews, events and special offers via video media.
Craig, we're looking at something different today, waterjet cutting. This is the Optima 420 from Kerf. Tell me about this machine.
This machine is effectively the Swiss Army knife of cutting machines, is how I look at it.
Okay, and you've actually got a part here that you've just taken off the machine.
Yes.
This is one type of application you can use the machine for?
It can be used to cut all sorts of materials, wood, steel, granite. Irrespective of what comes through the door, we've got a good chance we can cut it.
And how does the process work?
We get some water that's pressurised to about 60,000 psi. It comes down through a very tiny orifice, and then that mixes with abrasive sand. That process then goes through and cuts the material.
And what aspect of it is actually cutting the material? Is it the water or the sand, or a combination of both?
On hard materials it would be the combination of the two. If it was softer material such as wood, it can be just the power of the water that would cut it.
Okay, and why have Kerf, I mean, you're obviously very successful at selling your plasma cutter machines and your oxy-fuel machines. Why the waterjet into the range?
The attraction with the waterjet is it can cut a wide range of materials, but it can do it very accurately as well. And the finish that we can achieve with the waterjet is excellent.
So it takes you into a different group of opportunities in markets?
Yes, people that are in subcontract profiling don't know what's going to come through the door the next day from their customers.
And this particular model here, the Optima 420, does that mean the capacity 420? Can you get bigger machines, smaller machines?
Yeah, the 420 relates to the table size on the machine. This one being 4 metres by 2 metres. We can supply the machine any size. We can supply it with a single head or with twin heads, as we've got here. Or we could have two independent heads that are controlled by the controller.
So if you had two heads, would that mean you could be cutting two components at the same time?
Yes.
So that would improve production?
It would improve production. You would slow it down slightly, but it depends on the nature of the product that you're trying to cut.
I'm thinking sand here. What happens to the, call it the remnant sand, or the sand that once it's done its cutting?
If you were to run it as we've got here, in its basic format, then after a year or so you would need to take the machine apart and dig the sand out and all the remnant parts of the material.
So a better solution would be to opt for something that does that automatically?
Yes. What we can do is put jets around the bed of the machine that agitate the water, and then it's recycled into a scrap bin.
And then from a consumable aspect, what about the nozzles? How long do they last? Does that affect the profiles that you're cutting if they're worn? What about all that side of things?
The nozzle, depending on the speed at which you cut in and the power of the water that you're using, can last a month, can last a week. That's the only part that will wear.
So that's the only wearable consumable part on the machine?
That and the little diamond orifice or sapphire orifice in the centre of the machine, that can last typically a year.
And with the sand, we've got two, call them drums here, or you've got a bigger drum at the back of the machine where the sand is held that's fed to these, is that correct?
Yeah, what we've got at the back is a pressurised system that then feeds up through the clear pipes into these, and then we set the amount of garnet that comes down and mixes with the water.
That was going to be my next question. So you set that, that's not done in the control, is that done manually?
It's normally done by the computer software that we would use, the CAD/CAM software.
So if I had a specific material or a metal, the software would be able to indicate to me how much I need of the sand in comparison to the water?
Yes, I mean basically all I do is describe the material, the thickness, and the software will set everything. It'll set the speed, it'll set the quality, and it'll set the amount of sand that we need in the process.
Let's have a look at some more components that you've done on this machine.
Okay.
So what have you got there then, Craig?
This is a piece of aircraft aluminium that we've cut on the waterjet.
Okay, and looking at that, why would I not machine it out of a block or a billet maybe?
Well, you could machine it. The attraction with the waterjet is that we can cut the nearly finished part size and just take the amount of material that we need.
So I suppose if you were to machine it, there'd be a lot of wastage of material.
Yeah, if I was to machine that from a solid block, for example, there would be a lot more material used. It'd be a lot more machining and a lot more hard tooling or tooling for the machines.
Okay, and then underneath that, you've actually got a Kerf sign. Interestingly, on this, how have you managed to perform these angles on machining?
Okay, well, the other parts that we've looked at have all been done with a 3-axis process, where we're just moving X and Y and the depth. On this particular machine, we can have a 5-axis head fitted. So we'd use the same process to cut the letters and the holes out, and on the outside we'd use a 5-axis head to actually come round.
Okay, that opens up a lot of different possibilities then, if you can do 5-axis positional type machining.
Yeah, it's. One attraction is it's not just a profiling system. You know, it can cut parts from a plate. It will save you material, and it will save you a lot of machining time.
And then there's a component here that you certainly couldn't do on an oxy-fuel machine or a plasma machine.
On an oxy-fuel. No, you'd struggle to get that on a plasma machine or an oxy-fuel machine. It's just a little bit of perspex that we did as a sample.
Okay, and then we've got a bike here as well, and again this is just a nice, I suppose, a novelty item.
Yeah, a nice little demo piece. We can go from small bicycles all the way through to large bicycles. It's the flexibility of the process. This, for example, nice piece of expensive high-grade material that we can cut, and that's as it comes off the machine.
And I suppose the same applies to that as the previous part. To machine that out of a block or a billet would be far more expensive.
Yeah, and as I say, if we needed 2 of those, we could nest those together in the software.
And these Waterjet machines then, Craig, they're available from Kerf Developments here in Rochdale, service, support and the whole thing? Yeah,
what we try to do is look at the application for the customer, work together to see what size of the machine they need in terms of thickness capability and the size of the material they want to work with, and then we back all that up with service and support.
You mentioned thickness, that's one point I haven't raised. How thick can you actually cut?
The engineer claims that if it will fit under the bridge of the machine, it will cut it. So 200mm mild steel.
Wow, that's impressive.
Yeah, I mean, engineers, when I speak to them about Waterjet cutting, they struggle to grasp the concept that you can cut 200mm thick with water.
So just remind me of the audience for this again, for you guys.
On Waterjet, it can be anybody. It can be people doing kitchens, granite worktops. It can be people cutting aircraft parts where they don't want a heat-affected zone around the part, so they can cut finished parts with the Waterjet. The applications for water, unlimited really.
Brilliant. Good luck.
Thank you.
For more videos, products and news, go to mtdcnc.com or follow MTD Online on Twitter.